term. Okay, this is lesson 2. And so we're going to talk about sequences. So if you notice here in your book on page 102, since you've got your new groups, I want you to go ahead and complete this fairly quick. It shouldn't take you very long. In fact, I'm only going to probably give you 3 or 4 minutes. Okay, you don't have to necessarily jot them in the book, but I want you to go ahead and fill in the table. Okay, page 102. Otherwise, you can look up here on the board. That would work as well.
So we can just say the way this.
Yep, just fill in. It shouldn't take you that long to go through them. It says page 102.
Where we at? 9, that was 13. So on to minus 5.
Seven minus 5 is 2.
Negative 5 is 3.
4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. Minus 3 is 21. 7 times 4 is 28. Minus 3 is 24. 8 times 4 is 32. Minus 3 is 29. 4 times negative 2 is negative 8. Plus 5 is negative 3. 5 times negative 2, negative 10, plus 5 is negative 5. 6 times negative 2 is negative 12, plus 5 is negative 7. 6 times negative 7 times negative 2 is negative 14, plus 5 is negative 9. 8 times negative 2 is negative 16, plus 5 is negative 11. Alright, 4 times 3 is 12, minus 2 is 10, 5 times 3 is 15, minus 2 is 13, 6 times 3 is 18, minus 2 is 16, 7 times 3 is 1, minus 2 is 19, 8 times 3 is 24, minus 2 is 22, 4 times negative 5 is negative 20, plus 7, 5 times negative 5 is negative 25, plus 7 is negative 18. 6 times negative 5 is negative 30, plus 7 is negative 23. 7 times negative 5 is negative 35, plus 7 is 28. 8, negative 5, 40, negative 33, yes. There we go.
All right, so let's go through. What do we get for our answers up here?
Negative 1.
Negative 1?
0.
Okay, maybe I don't have that in there. Maybe I'll just have to write it. Okay, negative 1.
0. 1. 2. 3.
Okay, what about here?
13. 17. 21. 25. 29.
Okay, down here?
Negative 3. Negative 5. Negative 7. Negative 9. Negative 11.
What about here?
10, 13, 16, 19, 22.
22. Okay, what about here?
13, 18, negative 30.
Okay, so now I want you to look at the relationship between these equations that we have here and what the difference of between the terms is. So look at the difference between the terms and look at the expression that you have there. Okay, what do you notice? Yeah?
N and having,
Exactly. So the number in front of n. The number in front of n here is 1, right? So notice I increase by ones. The number in front of n here is 4. So what are you doing? You're increasing by 4. The number in front of n here is Negative 2, so every time you're subtracting 2. The number here is 3, so every time you're increasing by 3. Okay, the negative 5, you're subtracting 5 every time. Okay, so how you determine sequences is you look for your difference between terms. Whatever that difference is, that number will always go in front of n. So let's look at this one. We're actually going to write an expression like that one on before when you had like n minus 3 or negative 2n plus 5. We're going to write that here for this. And notice, each time it is increasing by 7. So what is my expression going to start with?
7n.
7n, very good. So now the question is, what goes right here? So this is what you need to think. N is 1, correct?
Yes.
So if I take the number 7, because if I plug n equals 1 in here, I get 7, right? What do you add to 7 to get 20?
13.
13. So you're always going to go to your first term because that's going to be the easiest one to find. And you're always going to say, okay, if I start with the number 7, what do you add or what do you subtract? And so let's see if that works. Let's plug in 5 for my 5th term. If I want to find my 5th term, I'm going to take 7 times 5 and add 13. What's 7 times 5?
35.
Does that in fact equal what is up here? Yeah, so that is correct. So you're going to take your difference between terms times n, and then you're going to figure out what number do you need to add there to get your first term. So if I was filling in my chart here, I would put 7n plus 13. And they're going to ask you to fill charts in, and that's what you're going to do. That's what it means when it says n. Okay, let's go ahead and look at another one. Now this one isn't in a chart, but we still do the same thing. So I'm going to look for my difference between terms. So what am I doing between each of these terms? I'm subtracting 5. So how do I start my expression?
Negative 5n.
Negative 5n. Now I need to think. Remember, I'm going to look at that very first term. How can you get 7 from negative 5? What do you have to add? Now, for those of you that are kind of wondering, oh, I got negative 5 and I need to add some number here so that I get 7. Easiest way to do this? Bring the 5 over. It's just an expression. Okay. And so it's plus 12. Now, once again, we could check. We could say, okay, here's 1, 2, 3, 4, 5. So here's my 5th term. So let's plug in 5 in here. What's negative 5 times 5? Negative 25. If I add 12, do I get negative 13?
Yes.
Yeah, so here is my rule. Negative 5 and plus 12.
How do you know if you subtract?
Depends on whatever number you start with. Okay? If that would have been, let's just say it would have been a negative 7. Instead of being a positive 7, if it would have been a negative 7, oops, let me grab my pen. If it would have been a negative 7 as my first term, what would you have added to negative 5 to get negative 7? Negative 2. So it just depends on whatever your first term is. Okay, now, could I have written it this way? Yeah. It doesn't matter. Questions? So now, what we're going to talk about is function notation, and this is something you've seen. You saw it last year when we discussed functions in algebra. It says function notation can be used for rules of sequences. So what you will see a lot of times is you will see f of n. Okay, it can be f of x, it can be f of n, doesn't matter. But what it would be, let's just do this. Well, let's not make that a 3. Let's even change that and put a 2 in. Okay? So, basically, if this was my sequence here, what would the numbers jump by? 2, because that's the number in front of your variable. So this one would jump by 2's. What are the numbers going to jump by down here? 3. Okay, the reason why they're going to jump by 3 is because it's the number in front of the n. So all that function notation does is it now puts it in an equation. So instead of just focusing on this part, we're just adding an equal to sign. Okay, that's all we're doing. Okay, linear functions are rules which generate a sequence with a constant difference. Every one we looked at was a linear function. So I see some of you are writing that down, so I'm going to let you write that down before I talk any more about that. What is the root word in linear? Line. Basically what they're saying here when it says a linear function, it's basically just something that would create a line. So if we were to plot points for every one of those sequences, okay, so let's go back here, look real quick. If I was going to plot a point, and I would plot the first point at 1, -4, then 2, -3, then 3, -2, what that's saying is that I'm just going to get a line. Okay, if I were to plot points at 1, 1, 2, 5, 3, 9, I'm going to get a line. Everything is going to lay in a line. And so that's all that's saying. Okay, it's just basically a constant difference will allow you to do a line, and believe it or not, the constant difference is actually the slope of the line. Okay. So remember we looked last year, 3n minus 2 would have a slope of what? 3. Y-intercept of? -2. So see how that all relates into what we learned with algebra? What would this have a slope of? 2. Y-intercept of? 5. And so if we were to plot all those points, that's going to be the line. So now, any questions over the sequences we've looked at? This is what I need you to do for me for tomorrow. I need you to do 1 through 7, 10, 17, and 18. Okay?